Okay, so for this one, we're going to look at finding the acceleration of some kind of a round object rolling down an inclined plane. And to do this, first we're going to start with a free body diagram. So here's the forces acting on that object. We've got normal force, friction force, and it does not add to zero. It adds together to rotational and translational motion. So we've got our free body diagram and kinetic diagram all mapped out here. To start, let's go ahead and take the moment around the point of this object that's touching the ground. That'll get rid of having to worry about normal force and friction force. So R cross F, and the perpendicular component that we're looking for here is going to be mg sine theta, so the tangent part. Remember, this is a cross product. Make sure you have the right angle in here, so that is going to be opposite or mg sine theta. So here we've got the radius of our round object times mg sine theta, and that gives us those two perpendicular chunks. So we have, this is actually a negative moment. It's clockwise. It's going into the board. Okay, on the other side, remember for kinetic diagrams, we're doing the same thing that we did for the free body diagram. Because we have it around the ground, it's from the ground to the translational motion plus the rotation around the center. So that's the inertia with respect to the center of mass on this. Now, some interesting things when you look at inertia, and of course, every object has a different inertia, right? But you'll find something in common with all these round objects. They all have mr squared in it. You know, one is 2/3 or 1/2, but they all contain mr squared. So if we go back to our equation and just kind of make a generic equation using that mr squared, we see some interesting things happen. And that is, we have r times m on each side of this thing. And so the acceleration of the round object ends up being independent of mass, independent of radius. It is purely a function of kind of that constant for the moment of inertia. So different objects will have different moment of inertias and will have different constants. So very interesting result that the acceleration is independent of mass and radius of the object.